This is a data frame consists of multiple rows and columns, can be viewed as collection of multiple series. Also, it has an index associated with it. Data frames and series are quite similar in that many operations, such as filling in null values and calculating the mean, but first we have to learn how to create them. First, we have to import Pandas library. Here, PD is used for aliasing. Next, print the version on Pandas that I'm going to use, which is 0.24.2. Now it's time to create series from scratch. Here I declared a numeric list of values from 1 to 6. Next, I call Pandas series function to convert the list into a series data structure. Finally, I print the series. Notice in the output cell that we have two columns. The left column indicates the default index number, while the right column represents the series values. We can give index values by ourselves. In the next code, I have created a list of index values. Again calling the series function, but this time with data and index both. Print and get results in a series of values with the defined index values. Okay, now create a series using Numpy methods. First, I imported the Numpy module. Next, I called the random method to generate 10 random values and pass it to the series function. Print and get results in a series of 10 random values. We can also use Numpy repeat method to repeat a value or a set of values. Here I passed 0.5 and I want it to be repeated 6 times. Later, I wrap the result in a series method so the resultant is a series of 0.5 repeated 6 times. This is how you can create series from Pandas library. Now moving on to data frames, which is our main agenda. A data frame is a two-dimensional data structure and it is an in-memory object. To create a data frame from a list, dictionary, and dimensional array, we use data frame method from Pandas. Here, I provided a dictionary having cities and provinces as key values. Later used the Pandas data frame function to convert it into a data frame named frame1. This is a data frame in the output cell. You can also load a data set in a data frame for further processing. Here, I load an iris data set which represents the flower measurements using read_CSV method. I pass the column name to it from a list. This is how a data set can be loaded into a data frame. The read_CSV method loads data set into this particular object. Later, I called it. The output displays the iris data set with given column names. That is sepal length, sepal width, petal length, petal width, and class. Let's discuss about importing and exporting different types of data sets. First, I want to discuss importing and exporting CSV files. We can use Pandas read_CSV method to load a CSV file into a data frame as we did earlier. Now I displayed the top 5 rows using the head method. So these are the top 5 rows and these are the columns. Next, if you want to save data frame into a CSV file, you can use the CSV method. First, I created a data frame from a dictionary and later exported it into CSV using to_CSV. I also passed the column's name to it, brand and price. Also, parameter index is set to false, that is index of data frame should not be saved, and set header is equal to true to set column names. Later, I print the data frames too. Here is the data frame with default index and brand and price columns with data values. Let me show you the CSV file. See, index is not a part of it. It only contains the brand and price column with data values. Let's get back to Python. Again, I want to reiterate that index is not saved. Now, let's move to Excel data format. First, I imported the Excel data of university students using the method read_Excel and passing the Excel file name to it with extension. Next, print the top 5 rows of my loaded data frame. See, it's very easy to import an Excel file. We can also import data frame into Excel file using to_Excel method. Here, I exported the tip.csv file data frame that we loaded earlier into an Excel file named output_Excel. And next, printing the top 5 rows of it. Let me show you both Excel files. This is the file data that we imported earlier using read_Excel method. And this is the exported Excel file, the one with the tips dataset. Now importing JSON data. Here I'm going to read a product file written in JSON. In JSON, we have key value pairs. The read_JSON load JSON data into a Pandas data frame. Next, I use the head method to explore the data values. So this is the products.json file. Next, before exporting, I filtered products based on price. Say, if price is greater than $500, then retrieve such products and create a new data frame from it. First, access the column of your data frame, next pass the condition in the square brackets. So this is the new data frame. Now I call the to_JSON method to save my data frame in JSON format. Pass the file name with extension JSON. See the file. It contains only those products that have price greater than $500. Pandas provide a variety of functions that can be applied on data frames. First, let's load the dataset using read_CSV method. Here, I loaded the tips.csv file with the restaurant's billing information. Name of my data frame is df_tips. Next, we have two functions to explore it. The head function returns the top 5 rows of a dataset. So these are the top 5 observations. Whereas tail represents the last 5 rows, as you can see in the output cell. We can also find the name of all features using the column property. Call your data frame with column property. It returns the name of all columns from the dataset. You can also access a particular column by accessing the column name after a period. So it displays the day column only. Moving to indexing and slicing. There are multiple ways to select and index rows and columns from Pandas data frame. We have lock and Ilock methods. Suppose I want to access time column and all observations. In lock, I pass 2 parameters, row selector and a column selector. To get all rows, use colon operator with no start and ending index number. And in column, I pass the column name only. See the output cell. All observations of time columns are displayed. Next, move to Ilock. The Ilock indexer for Pandas data frame is used for integer location-based indexing or selection by position. Ilock in Pandas is used to select rows and columns by number in the order that they appear in the data frame. Note that .ilock returns a Pandas series when one row is selected and a Pandas data frame when multiple rows are selected, or if any column is full is selected. When selecting multiple columns or multiple rows in this manner, remember that in your selection, for example 1:5, the rows or the column selected will run from the first number to 1 minus the second number. So here I'm accessing all rows and second column of data frame. Similarly, you can access all desired rows and columns. Here it is displaying the total bill column. Now I want to access top 5 rows and all columns. So pass 1:6 and in column selector pass a colon only. So you get the top 5 rows with all columns. Next, filtering. Suppose I want to extract female customer orders. So access the sex column and equate it with female and set it as a condition in the index position. Next, I pick the top 10 values using head function. You can also fetch all values by removing this head function. In the same way, data of male customers can be accessed. Moving to Boolean indexing. What do you do if you want to filter values from a column based on condition from another column or a set of columns? This can be done using Boolean indexing. Suppose you want to find the list of female customers that had their lunch on Sunday. Create a data frame using AND operators as it is necessary to meet all three conditions. Next, I pass the output as Boolean indexing to my data frame. The result displayed the desired result. But what is the val variable? Let's print it. It returns true or false against each observation. So this Boolean result is passed for indexing. We can also find unique values from a particular column. Suppose I want to know the unique values present in the sex column. The code returns male and female. Similarly, you can access any other column, say for example time. It returns lunch and dinner. We can also get duplicate rows using duplicated method. Here we have no duplicate rows, so it returns null. Moving to iteration. Create a data frame with columns A, B, and C. This is our data frame with columns A, B, and C. We can fetch each data frame element one by one using method iterRows. Apply a for loop to sequentially access data. The iterRows method returns row and index. I use row and call column names to access individual elements. So we get 1, 2, 3 from first row, 4, 5, 6 from second, and so on. Moving to concatenation operation. We can join two or more data frames using concat method, which results in a new data frame. Here I declare two data frames which has been created from dictionary. Frame 1 and frame 2. Printing them, both contains same columns, city, and provinces. Now using Pandas concat function to concatenate them. Here I use drop_duplicates method to remove duplicate values and reset_index method to reset default index values. We have Karachi as value in both dataset using drop_duplicate method. It is not repeated twice in the final data frame. Also, sort is set to true to perform default sorting. If I remove reset_index method, the index number of both data frames remain intact, and you can see that 0, 1 is repeated again. Let's move to sorting. Use column name that you wish to be sorted in the sort_values method. Here, provinces is used. Now, the output cell displays the provinces in ascending alphabetical order. You can change the column name to cities and see the effect. We can also combine data frame based on values in shared columns. This is known as merging. It offers more flexibility compared to concat as it allows combinations based on a condition. Here I am merging frame 3 and data 3 based on provinces as this is a shared column. See the result. Province column is not repeated. Here is the result. Quetta is the city, province is Balochistan with 12.34 million population. Again, checking filtering. We can filter results based on a particular value only. Say, I want to see the result of data with Lahore as city. Pass this condition to the data frame. Next, move to pivoting. The pivot function is used to reshape a given data frame, organized by a given index or column values. This function does not support data aggregation. Multiple values will result in a multi-index in the columns. First, create a data frame from a dictionary, the restaurant data frame as columns. Mobile, store price, and ratings. The pivot function returns reshaped data frame. It requires 3 parameters: index, columns, and values. An index parameter pass column to make new frames index. If none, the method uses the existing index. For columns, pass column you want to make new frames column. This parameter is mandatory. Lastly, for values, pass a column or multiple columns for populating new frames values. If not specified, all remaining columns will be used and the result will have hierarchically indexed columns. Here I passed index is equal to mobiles, columns is equal to store, and values is equal to price. So at index position, mobile names are displayed. For columns, we have store values. And price is used to fill the values for the data frame. So Amazon and Walmart are columns. We have NEN values where there is no value in original data frame. To see hierarchically indexed columns, remove value parameter from the list. And now a hierarchy is generated in column. As you can see, Amazon and Walmart as column is repeated twice, first for price and next for ratings. We can also use stack method to stack the rows values vertically. Use the stack method provided by Pandas. And see each observation is returned as a stack. You can stack the values using unstack method, using the same stacked result. I applied unstack method over it. Now we get a tabular representation. Melt function is used to unpivot a data frame from a wide to long format, optionally leaving identifiers set. This function is useful to get a data frame into a format where one or more columns are identifier variables, while all columns considered measured variables are unpivoted to the rows axes, leaving just 2 non-identifier columns, variable and value. In id_vars, we can pass tuple, list, or ND array. It is used as identifier column. All the remaining columns are treated as values and unpivoted to the row axes, and only 2 columns, variable and value. Here I passed a list having mobile and price in id_vars parameter. In the result, we have these 2 as column. We can pass the var_name and value_name parameters to change the column names of variable and value. Moving to append operation. I can append one or more data frame with another data frame. First read 2 data sets and get 2 data frames, df1 and df2. Next, I appended df2 and df1, setting sort to true. Both data frames have same column names. And the resulting data frame values are appended along axis 0. Both df1 and df2 remains unchanged. Indices can be reset using reset_index method as seen earlier. We can add a new column to existing data frame. Suppose I added a column D in the existing data frame with these values. Print the data frame and see a column D is added. Similarly, rows and columns can be deleted too. To drop a column, set axis is equal to 1. I want to delete column C from my data frame. See the output, now C column is gone. We can also remove a row by setting axis is equal to 0 and providing row number in the index. Now the row at index position 4 has been removed. Missing values can be filled using fillna method. Here in column B, I want NEN to be filled with double hyphen. Similarly, for column D, I want missing values to be replaced with 0. See the results. We can also replace values from a data frame. Load an Excel file containing students' progress. It has a column grade, having values A, B, and C. Now I want to replace them with numeric entries as it is often required in data analysis. Use the replace method provided by Pandas. Access the desired column first. To_replace method passes the values that needs to be replaced, and in value arguments pass the new values. See now, A is replaced with 0, B with 1, and C with 2. You can also use not equals to operator so that observations is not removed but doesn't appear in the result. Suppose I want data of all students except the data of POH, so use not equals to operator. We can also find mean and other statistical values. Here I found the mean of the marks column in the mean value. We can also generate group by and cross-tab results similar to group by query in SQL and cross-tabs and pivot tables in Excel. Once again, load the tips dataset. Suppose I want to see the difference of mean values of features between smokers and non-smoker customers. This is how it can be achieved. Let me drop this unnamed column. Now group the data in similar manner, but with sex too. Now we can see the difference of values of smokers, male and females, and non-smoker males and non-smoker females. We can unstuck the value to see in wider format. We can also get a summarized result using pivot table. This is the mean value of tip. We can also find the mean value of tip according to day and time. Finally, using crosstab, I get the count of customers in each day. This is general overview of pandas and functions. Hope you learned a lot from it.